Okay, this video is to go over lesson 2 of unit 1. So we're going to be reviewing linear functions today. This is going to be an important topic because we're dealing with equations of lines throughout the course. So we need to know the different formats for writing the equations of lines, and then also how to model different scenarios in word problems. So the first thing we're going to review is slope. So slope describes the steep. The larger the value is for the slope, the steeper the line is going to be. So for example, you can see in the picture here, this line, so slope is rise over run. So you're going to count the slope from point to point. It's 3 down and 2 over. So it'd be 3 over 2. And because the line is, this graph is decreasing, the slope would be negative. So we always look at it from left to right. So if we have 2 points, to find the slope, we can just use the format of the equation y2 minus y1 over x2 minus x1. So the x values would be your x1 and your x2, and the y values would be y1 and y2. It doesn't matter which point you choose to be y1 or point 1 and point 2. You'll get the same answer in the end. So for us, the y values are 5, and x values are 4 and negative 7. So we're going to have 5 minus 4 is 1, and 4 minus negative 7 is 11. So the slope is 1 over 11. Okay. So the first equation we are going to review is the slope-intercept form. So this equation is best if you know the intercept, the y-intercept. So in this equation, the coefficient of the x, we label it m. M is the slope of the line, and the constant number, b, that we call b, is the y-intercept of the line. So m is the slope, and b is the y-intercept. Okay, so let's look at an example. It says find the equation of the line that passes through the points 0, 5 and 3, negative 7, and then graph it. So right away I can see this is actually the y-intercept because x is equal to 0, so that would be on the y-axis. So b in my equation is going to be 5. But I need to know what the m in the equation is going to be. So for that, I need my point slope equation, my slope equation. So y2 minus y1, x2 minus x1. So y2 is negative 7, y1 is 5. Again, you can do it in the opposite order, doesn't matter. 3 minus 0. Negative 7 minus 5 is negative 12. And 3 minus 0 is 3. So that's negative 4 is the slope. And so I can write my equation y equals negative 4x plus 5. I'm just going to use the same colors to highlight so it matches above. Okay, so we just happened to be given the y-intercept in the question, and so that's why it made sense to use the slope-intercept form. And when you're graphing it, you also start with the y-intercept. So start with your y-intercept, which is 5, and then count the slope. So for us, the slope is negative 4, which means I'm going to go 4 down, 1, 2, 3, 4, and 1 over. 1, 2, 3, 4, 1 over. 1, 2, 3, 4, 1 over. Once you've filled out the whole graph, 1, 2, 3, 4, 1 over. And you want to draw a nice straight line through your points. Okay, so that's the slope-intercept equation, mx plus b. The next is going to be an equation you would use if you don't know the y-intercept. You can use the slope-point equation or the point-slope form. So this equation comes straight from the slope equation of a line. Y minus y1 equals mx minus x1. here we still have this m, which is still going to be the slope. But instead of the y-intercept this time, these two constants are going to be a point on the line, and it could be any point on the line. So x1 comma y1 is going to be a point on the line instead of the y-intercept. So let's say we had this question. It says find the equation of the line that passes through 3, 7. So that's going to be our point and has a slope of 3/4. So the x value in this point is x going to be our x1, and then the y value is going to be y1 in the equation. So y minus y1 equals m, x minus x1. And so here is our point. That's where we plug those in. And then that's where we plug our slope in. So we'll have y minus 7 equals 3/4 x minus 3. So there's your equation. You can rewrite that using algebra as the slope-intercept form, or you can just leave it like that. And so to graph it, you start with the point 3, 7, which is right there, and then you count up the slope. So in this case, I'm going 3 up, 1, 2, 3, and 4 over. 1, 2, 3, 4. Or you can go down 3 and 4 to the left. 1, 2, 3, 1, 2, 3, 4. 2, 3, 1, 2, 3, 4. And once you have filled up the graph with your points, you draw a nice straight line through them. And there's your graph. Okay, so those are the two equations that we're going to be seeing, or the two types of equations we're going to be seeing, slope intercept and point slope. We're going to do two application questions now. So the first is about antibiotic resistance. So from 1997 to 2003, there was a study on the issue of antibiotic resistance. The linear equation here represents the percentage of diagnosed gonorrhea cases, and the variable x represents the year. So y is a percentage and x is a year. So what is the slope and what does it represent? So for this question, we can just read off, I'm going to use the same colors, the slope just from the equation there. And we need to write the correct units. So units for slope. So slope is m equals change in y over change in x, right? That's one of the formulas for slope. So to get the units for slope, all you do is take those exact same units. So y for us is a percentage. So for us, it would be percent, and x represents the year. So there are our units, percent per year. So that's the units for our slope. So it's going to be 4.9% per year. And it represents the fact that the number of antibiotic cases is increasing. So slope is always a rate. I'll write that here too, is a rate. So it's the amount something is increasing by or decreasing by. So in this case, because it's positive, it's increasing. So the number or the percentage of resistant cases is increasing. I'm going to write that in capital letters by 4.9% per year. Okay, so in your answer, if a question asks you to describe what a slope represents, I should always see this increasing or decreasing in your answer, because slope is a rate. So if it's a positive number, something is going up by a certain amount, it's increasing by a certain amount. If it's a negative number, that thing is going down by a certain amount. Okay, and you should always have the correct units in your solution as well. Okay, so what percentage of cases were resistant in 1999? So that's just using the formula. Okay, so we have y equals 4.9, and the number they give us there is an x value, because x represents year. So if you have any time is always, most often, 99% of the time is going to be an x value because it's an independent variable. So we're just going to put the year in there, and we will get 4.9 times 1999 minus 9783.9, 11.2. So the answer would be 11.2%. The word problem, you should always include units in your final answer. In what year did the percentage of antibiotic cases reach 25%? So in that case, they're giving us a Y value. So we're going to use the equation again and have 25 here, 0.9x, and we just have to do some algebra to solve for x. Okay, so we'll bring the constant term to the other side by adding it, 9783.9. Okay, so we'll get 9808.9 equals 4.9x, and then we'll divide both sides by 4.9. X equals 2001.8. So the year would be 2001. So during the year 2001, the number of antibiotic resistant cases reached 25%. Okay. So that's example one. That's where you're working with a slope-intercept equation. The next example, we're going to be dealing with point slope form. Okay, so a company produces insulin prescription medication to help treat diabetes. Currently, they spend $1,500 to produce 100 batches of insulin. So I'm just going to highlight that. The marginal cost, the rate of increase of cost, is $10 per batch. So when you see that per, that's often an indication that that is a rate. $10 per batch. That's going to be our slope because it says increase, right? So that's another key. So this word marginal is going to come up throughout the course. It just means rate of change in. But you don't need to know that for now. Even without knowing that, you can just look at the units and tell that this is the slope. Okay, so they give us 1 point. They say that 100 batches of insulin cost $1,500, and they give us the slope. So the best equation to use is point slope form. If you want to pause the video now, you could try this question yourself, or you can do it along with me. So we have a point on the line. Now, it tells us X is the batches of medication right here, right? And C is going to be cost. Cost is going to be the Y value. So our point is going to be 100, 1,500. And our slope is going to be $10 per batch. Okay. And so I'm just going to plug it in. So instead of Y, it asks us to use C of X here. So instead of Y minus Y1, oops, what happened? Hold on 1 second. My notebook just went away. Okay, I'm just going to reshare it. There we go. Okay, it should be working now, hopefully. Okay. There we go. Okay, so to produce, oh no, okay, yeah. So instead of Y minus Y1, I'm going to do C of X minus, okay, so my point is 1,500. And then I get M X minus X1, X minus 100. It's the same format, except for Y, instead of Y, I'll use C of X because the question asks us to write it in function notation. So there's my point in blue and my slope in yellow. So that's my equation. You can leave it in that form if it doesn't specify what format you need to write in. It says, how much would it cost a company to produce 250 batches of insulin? So C of X, we want to find the cost. We don't know that, but we do know we want to produce 250 batches of insulin. So I'm going to put that in for the X value. Okay, so now we just have to do some math here. So I'll move the 1,500 to the other side and evaluate that bracket. It'd be 10 times 150, so it'd be 1,500 plus 1,500, which is going to be $3,000. That'd be $3,000. And cost is in dollars, so I've got the correct units. I'm just checking my answer key. Yeah, that is correct. Okay, and lastly, what is the fixed cost of producing insulin? So this will come up once or twice in your assignment also. So I'll just define fixed cost here. So note, fixed cost is the cost when producing 0 batches. So for a company, right, if you produce no material or no merchandise or whatever you create, you're still going to have some cost because you're going to have some storage costs or maybe some costs for employees or costs for materials or equipment. So even if you're producing nothing, there's still some costs associated with your business unless you completely shut down. So it's the cost when X equals 0 and the amount of batches is nothing. So when you're producing 0 insulin. So we're going to use our formula. Of 0 equals, so it would be 10, oops, I forgot the 1500 part, minus 1500 equals 10, 0 minus 100. So I'll add 1500 to the other side, and I get negative 1,000 plus 1500. So it's usually a positive number. So it's $500. So when this company produces no insulin, they still have a cost of $500. Maybe that's equipment, maybe that's employees or insurance or whatever. Okay, so that's it. So go and do assignment 2 now on linear functions.